okay, neon. Now, as I was filling this up pretty quickly, 1s, 2s, 2p, 3s, 3p, 4s, 3d, I can see from this drawing how one should fill electrons in the lowest energy level, but there's actually a way to follow it in the periodic table. If you look at what we just did, hydrogen had an electron configuration of 1s1, helium was 1s2, lithium was 2s1, and then it went 2s2, and then we started over here 2p1, all the way up to here was 2p6, was the last orbital filled with the 6 right here. Looks like that. It would be neon, since it's filled all the way up to there, it's 2s2, 2p6, because the p fills up as you move across. And then if we move back down to sodium, what's the electron configuration for sodium? The next higher energy level is the 3s. And what you'll notice is if we continue to add, we say what is the electron configuration for aluminum, you can figure it out without going through all of that, just by knowing that every period on the periodic table, as you move down, you're starting to fill the next higher energy level. 1, 2, 3. So the energy level that you're filling matches the period number or the row number. So 1, 2, 3, 4, 5, 6, 7. 7 periods in the periodic table. And as you go across, you fill up first the S in that particular given energy level, and then you move over here for aluminum. If this is the 3s and I filled it because there's one electron here and another electron there, if I get to the aluminum, which has 13 electrons, then it's going to be 1s2, 2s2. I'm going to fill all the p's here, so it's 2p6. I'm going to come back around here, fill the 3s's, and then move over here and start filling the p again, 3p1. So I can, the electron configuration matches onto the periodic table. We can also do the noble gas shortcut, because every time you get all the way across to the last column in the periodic table, column 18, or the noble gas group, you know that you have filled a core, and so that goes over to 2p6. That all looks exactly like neon, so you can do the shorthand and just say neon 3s2, 3p1. Alright, and as it turns out, the periodic table is a great guide to help know the order of the filling for the electron configuration. So the order of which energy level is the next higher energy level and how to fill it is called the Aufbau principle. That should be an F. Try again. Aufbau principle, which means to build up. And so we use the Aufbau principle, and it maps onto the periodic table beautifully. The only thing is, when we get down to the 4s, this part of the periodic table is actually called the s block, because you're always filling s orbitals as your last orbital filled for the elements in there. This over here is called the p block, and the transition is called the d block. And so remember, when we looked at the way the energy levels degenerate here, or lose their degeneracy, the 3s is less energy than 3p is less energy than 3d. However, the 4s is of lower energy than the 3d. So when you go past the 4s right here, this is 4s1, 4s2, then the d block, it's actually dropping back down to 3d right here, 3d. So the d block moves with the energy levels, whereas the period number matches the energy level for the s block and the p block. The d block is actually n-1 on the energy level. Okay, so then it's 4s2, 3d, and the d has 5 different orientations. Each one can contain 2 electrons. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements here, and as you move across the transition elements, it's 10 elements, and that fills the d block because there's 5 orientations, each being able to hold 2 electrons.